But before we do you guys have questions about anything? Okay, so I'm working on getting your midterm specifications up later tonight. But what you're going to be doing is you're going to basically be making Connect 4, but it's called Connect N because we have to choose how many pieces we need. And we're going to be using curses, so you can see I can like move the little piece over, and I can drop it down, and eventually, you know, someone can maybe win, and then it'll tell me like who won. And so that's what you're going to be implementing for your project. And there'll be more details about it coming up. Yeah. So one of the things that we're gonna have to do for testing purposes is you're gonna have to like log changes to the state of your output to a file so that we can test it, because I can't just simply like redirect curses output to a file and then expect it, because it puts a lot of weird command line characters in there, and you might use different commands to move your cursor around than I do, so our results wouldn't diff correctly. So part of the specification is you're gonna have to like, every time I do something that like changes what my output looks like, so every time I do something like I move the character over, my output looks different, so you'd have to go print the entire screen to a file, and you're gonna keep like appending that to a big file, and so you have like the entire state of the game as it's played out. Does that make sense? Any other questions? Testing should hopefully come soon, later this week. It still will be submitted on Codathon. You can still work with somebody else if you want to. It'll be in pure C still, and eventually we'll get to C++. We'll have 2 weeks to work on it. It has to use NCurses. I'm not sure how else you're going to get it to do this without it. Any other questions? Yeah. We'll be transitioning to C++ on Wednesday or today, depending on how long what we're doing today takes. Okay. Hopefully you guys all got your homework done, or if not, you're going to get it in by the end of tonight. That's when it's due. Discussion today, I'd originally planned on this week doing CMake, but I kind of decided it might be a better idea just to double check that we're all on the same page and we have everything down. So we're going to be using this week's review sessions or discussion sections for review to catch you up on things that you're still having issues or trouble with. So if you have questions about things going on in the homework, also today would be a great time to stop by. But back to curses. I think last time we kind of ended here about getting input. So getting input's pretty easy if you want to get input from the standard screen. Get ch will get you a single character. Move and get ch will move you, get you a character. Get string gives you a string. The user has to type until they finally hit enter. Get end string will read again a string until they press enter, or up to n characters. Then you have the movement versions, which will move you to some location before they start reading the input. If you just want to move the cursor, it's move, and you say where you want to go to. Notice again that like everything in curses is always row, column, row, column, row, column. So pay really careful attention to that you're moving by rows and then by columns so that you end up at the right spot. And so finally, when you want your stuff to show up on the screen, you do refresh, and it's going to cause the virtual screen to be transferred over to the physical screen. Sometimes you might have multiple windows that compose your physical screen. We'll talk about windows in a second. And if you want a more efficient update, what you can do is you can call wnout refresh on each of those. And what that's going to do is curses will figure out what's changed from the physical screen and what changes you have made to the virtual screen. So like what are the differences on each of those windows. And then when you call do update, it'll actually go and put those updates onto the screen. So if you have multiple windows that you need to update the output for, it's generally faster to wnout refresh all of them and then call do update to get the screens to show up. Otherwise, if you do each one run right after another and you can call refresh in between, it can cause a bit of flashing. So while STD screen represents the entire physical screen, it can be really, really useful to break the screen into many smaller logical units, each dedicated to some kind of certain task. For example, I have 3 different windows for that NCurses problem, or for the connect end problem. I also kind of recommend that you don't use STD screen ever, because if you decide later on that you need to add more window areas to your program or to your code to make it work, standard screen always is in reference to absolute positions. But if you had it done inside a window, even if that window was taking up the whole screen, you can now make it smaller and put stuff next to it, and you wouldn't need to change any of the code inside of it. Just that one line of code where you created the window to be a different size. So it makes, like, you know, refactoring your code and doing updates a lot easier. So use the windows. So if you want to create a window, there's a couple of different versions you can use. There's newWin, dirwin, and subwin. Newwin will create you a brand new window that's numRows by nums call big, and it starts at start row start call. The very upper left-hand corner of your screen is 0, 0. So if you want to start at the very beginning, it's 0, 0. Dirwin and subwin, they both create sub-windows inside of a larger window. One of the 2 differences is that dirwin is its relative to the original parent window's location, whereas subwin is just an absolute position on the screen. And if you're using dirwin or subwin, you need to first touch the original window called touchwin, which just like means that everything needs to be updated, and then you can go and you can refresh the sub ones. One of the differences between like the sub windows and the new windows is that the new windows are all going to share a virtual screen with their parent window. So if you modify the child window's virtual screen, the parent's window's virtual screen will also update. Or if you happen to go to the parent's virtual screen and you modify the portion where the child lives, the child's virtual screen will also be modified. If you're using newWin, it has a completely separate virtual screen. So even if this you have 2 separate windows created by newWin that like physically overlap on the screen, changes to one's virtual screen don't affect the other's virtual screen. Again, everything here has been about virtual screens. There's still one physical screen. And so the last one that you paint to the physical screen, that's the one that's going to show up. So if you have like, you know, 2 new windows and they're both lying over the top of each other right here, if you say refresh this one and then refresh this one, the top one, the second one would show up. But if you refresh in the other order, this side would show up instead. If you want to do operations on Windows, they're pretty much all the functions are the same, except you append a W to the front. So you can kind of think about each of the functions looks something like this. It looks something like, you know, original command, original fun, original function, and then you have the option for a W if you want it to go onto a window, and if you also want it to move, you put the move there in the front. So if you want to refresh a particular window, right, like W refresh, right? I want to refresh some window, and that window would be the first argument. If I want to get a character from a particular window, it's W get character. But if I want to move and get a character from a particular window, it'd be move W get character. Oops. Oh gosh. Go back. Right? Or if I want to add a string to standard screen, it would just be add string. If I want to add it to a particular window, W add string. If I want to move and then add it to a particular window, move W add string. Does that make sense in terms of the format of the instructions? Yeah. I have to go look at print W. I'm not sure. So there's also like wide versions of support for these functions as well. If you have like a wide character, we shouldn't be working with any of those, so we're not going to be talking about them. But I have to go look, because normally if I want to add, normally when I've been working with curses, I work like on a character basis, so I'm like W add char, like the entire time, because, you know, the user has like moved their, you know, their a piece 1 unit to the right. So I need to go put a character here and move the character over. Anything else? So you might want to get some information about some window. So get max y will tell you the number of rows. Get max x, the number of columns. Get cur y will tell you what row the cursor's on. Get cur x, what column it's on. Get beginning y and beginning x will tell you the absolute position of where this window starts at. The row for y and the column for x. If you want to actually figure out like what's on that virtual screen of some window, it's WNChar, and that'll tell you what's on the window. It's going to return the character as well as its attributes, like whether it's been bolded or underlined or what colors you've set it to. And then you can also like move and then get that information too, or you can get like entire rows worth of information using stir. So once you get that character back, that's a CH type, you might want to figure out like what's actually there, what's the text, what the attributes are. And if you want to, you have to do a bitwise AND, which is a single ampersand between two things to actually extract the values. So to get the text, it's char text. To get the attributes, it's A attributes. To get the color, it's A color. So if I just wanted to figure out what the character was, I would get the symbol from nchar and then call it with cur symbol and a char text. And that would just give me the character, whether it's like an A or a B or a C or an asterisk or whatever happened to be there. If I wanted its attributes, and it with the attributes. If I wanted its color, and it with the color. Yeah. So it's what's called a bit mask. So it's basically a series of zeros and ones. And when you do the ANDing, everywhere there's two ones in the same spot, you get a 1. If there's a 0 in any one of the spots, you get a 0. So it's used to kind of like manipulate the bits that are there, and it's going to allow it so that only the bits that represent the character to come through. Anything else? There are also certain attributes that you can turn them on the window level or for a particular cell. Attribute set will set the attributes to that window to be whatever you want them to be, but for the entire window, and it will set them to be exactly that. On will turn those attributes on, but not, if the ones you don't talk about, their state will remain unchanged. Off turns the ones that you tell it to turn off. The ones you don't mention stay whatever their state happens to be. The attributes can be one of blink, bold, dim, reverse, standout, underlined, or color pair. There's a lot. And if you want to do it with just a single character, you would OR it when you're writing it to the screen. So if you do like, A or A bold, A underlined, it's going to make that character appear both bolded and underlined when you put it to the screen. Does that make sense? Any questions? Okay. So what I'd like this to try doing is we saw that we had that tic-tac-toe problem from last week. And so what we want to do is we want to make it so that we can have a nice little screen that we can move around on and put the characters in there. So the first thing that we should probably do is we should make sure that we can actually use curses. So we're going to have to modify our CMake file to actually enable curses. I should also mention that if you guys are having like issues running the curses, so for me, if I just try to press play on the curses program, it'll try to like do it in like the C line kind of like text display area, and it does not work. So what you can do, if I debug it, it will show it to me, and so I can put a breakpoint where I want to like after the end of the program just to see everything. But you can also try running the program from inside the terminal, and then look at what's going on down here. And then if you want to debug it in the terminal, so like cd into CMake build debug. And so you can see that I'll make sure to build this. So if I go back to the terminal and click the screen, you can see I have the summertictactoe.exe, so /summertictactoe.exe, and it'll start playing. And so now if I wanted to debug this program once it's running, some of you might have to do it this way, you go to run, attach to process, and then we're going to go look for the program. So summer tic-tac-toe.exe, and now we've put the debugger on there. And so if you set the breakpoints in your code, like normally it's actually going to stop there. But some people have had issues where like they can't launch it through the debugger and it won't work. I think it tends to be people that are running on Mac. So that's how you can get it to run. You run it through the terminal, and then you go attach the debugger to it afterwards. Then you can go set the breakpoints, and then it works just like normal. So first thing for changing the CMake files, we're going to go back here, and we're going to add these lines of code. So we're going to want to use NCurses right here, and then target the link libraries and target the include directories. This goes after the add executable line, so after line 10. And now we reload our changes. We're able to compile curses. Not exe name. The name of our exe name is summer tic-tac-toe. And great, now we can compile with curses. One issue that I've had when working with curses is that like when I use NCurses, it'll actually build and compile and work, but it keeps complaining that it can't find them. Don't know why that is inside CLine. I just can't find the curses directory, even though like it's obviously able to because it's able to compile with it. So we're now able to compile, and here was our game. Where's me? So here was our game, right? We made the board, and this was like our main gameplay loop. So which things do you think we're going to have to modify in order to make it converted over to use curses? Probably something like printing the board, right? It's probably going to be showed up somewhere different. And we're probably also going to need to do something about how we get the move. That's going to need to be a bit different. And that might need to be it. We might also need to modify place move as well, so that when we place the move on our internal data representation of the game, we also put it out to the physical screen that the user can see. Does that make sense? So what do you think we should do first to get curses working? So we'll include curses so we can use the curses. And the first line of code that we have to run to get curses started is init screen, right? And do you think we should be making a function to do this kind of stuff? Or, I mean, like a function that's going to like encapsulate some of the setup? Or should we just do it here in main? Depends. We can start with it here, and then we can kind of like move stuff into functions if we need to. So the very first thing that we'll do is we will init the screen. What else might we want to do? We probably want to turn on no echo as well, right? So that no echo. And there's probably one other thing that we want to do as well. Yeah, sleep break. Right, that's so we're able to get the input right away. So we kind of like established some of the stuff. So now what do we need to do? So we want something to be able to represent our board. What might that be called in Curses terminology? A window, right? So how can we make a new window? Right, we have a window, all in caps pointer, right? Like call it maybe like the board window is equal to it's new win. And then where do we want a new win? And where do we want our window to start at? Right, we'll start it, I think so the first thing is how big do we want it? We'll start it like simple, right? Like 3 by 3, right? And then we want it to be probably at 0, 0, right? Start in the upper left-hand corner. One thing I've also kind of found that makes dealing with curses like a bit of a pain in the butt is like whenever you put a character to the screen, it moves where the cursor is at, right? So like notice if like my cursor is right here and I press like the letter A, right? It moves me to the right by 1. So now I'm 1 to the right. This can be super annoying sometimes, especially if you want to like enable wrapping to make it like wrap back around the screen. Because like if the user's like on the left of the screen, you want to go left. And right now, depending on how we implemented it, it might cause us to stop at the left, but you might want to go back around to the right-hand side. So what we're going to do is we're going to have a struct here to kind of keep track of where the cursor's at, so that we can move it more easily. You can always ask cursors where it's at, but there are some things like if the cursor's at like the bottom right hand of the corner and you say like add a character there, obviously it'll work. But then the cursor doesn't move because it's at the bottom right hand corner of the screen. It can't go anywhere else. So you might have thought, you know, if I want to like put a character there but not move the cursor, I put the character there, right? And then I move the cursor back by 1. It doesn't always work because it sometimes won't move to the right. It's really frustrating. So we're going to actually create a new struct to help us out with this. So we'll call this like a cursor tracked window or something. It's going to be the name of our file. So since we're going to need to use curses in here, so pound include NCurses.h. And then how do we declare a struct? Yeah, we're going to use a type def because it makes it easier instead of having to type struct thing, struct thing, struct thing all the time. We might call it a cursor tracked window underscore struct. That's how I name mine. You can call yours whatever you feel like. And so we're going to need a window pointer versus win, and we're going to need to know like int cursor row cursor call, so that we know like where the cursor row and the cursor column are at, right? So we might have a new function that returns a cursor tracked window called like create, maybe like new cursor tracked window, and we need to int num rows, int num calls, int row start, int call start. Oh my goodness. No. Because we're using curses, it keeps complaining about like everything and not working right. Cursor track window. So what do you think we should do in creating a new cursor track window? Well, maybe we can go steal some of that code that we had over here in main. Oops. So window dot cursor win, cursors win equals new win, and then our window dot cursor row is going to be equal to 0, and window dot cursor call is going to be also equal to 0, because when you create a window, it starts in the upper left hand corner of that window. Any questions so far? Yeah. Oh yeah. I totally was going to do that, and num rows, num calls, row start, call start. Any other questions? So now over here, we're not going to have that. We're going to include curses tracked window.h. This should be renamed to .c. when you're changing the names of files, make sure to do them from inside CLion so that all the dependencies and stuff get updated. So I might have a curses tracked window board window equals new curses tracked window at 3300. Okay, great. So we've allocated this space for our window. What should we have it do after that? The space has been created. Maybe we should fill it in with something like whatever character we're using to represent our board, right? And so for us, we're going to use like asterisks, but we might have something that says like, you know, fill window, and we want to fill which window? Board window, and we want to fill it with asterisks, whatever that character happens to be. So now we go back over here and we define our new function void fill window. It takes in a cursor track window pointer when, and it also takes in a char, fill char. No, don't do that. I don't even know what it did. Okay, that's fine. Oh, whoops. Yeah, need to return window. Duh. See, even with all these annoying errors and it not working correctly, my code's actually correct. CLion's just wrong. I don't know why. Okay. So how might we go about filling this particular window with this set of values? And we don't want the fill to, at the end of the day, advance where our cursor's at. We want it to still remain at the same position, just fill the window, right? So doesn't advance cursor. Yeah, right. Which in some ways we kind of already, well, have. They're inside when, right? But you might say like int row equals when arrow cursor row. Cur call equals when arrow cursor call. Right? So we're able to preserve those so that we can reset them back at the end of the day. What functions do you think we're going to need from the curses to be able to put this character to the screen? Right? We either want like add ch, that'll add it where the cursor is currently at, or we might want to use move add ch. But we're doing it for a particular window, so it'll be like either w add ch or move w add ch to add it to that particular window. Does that make sense? But we also have to figure out some other things like how big is the window, right? Because we know we need to put the characters there. We know how to add them, but how many should we be doing, right? And so what functions might we use to help us figure out how big the windows is? Get max y, get max x, right? And if we want to, we can actually like wrap these functions inside of like another like function so that they're easier for us to call, so that we can call them on like a cursor tracked window as opposed to just having to like keep dereferencing all the time. So we might add some other functions over here, something like int get num rows of a cursor tracked window pointer when. I guess this one actually could be a const because I promise not to, well, whatever. We won't worry about the const right now. Sometimes it can be kind of annoying. But we should be better about using const. I know I should always use const more than I do. Okay, so what should get num rows do? We want to return get, right, max y. I always get those messed up. Max y of window. Arrow, cursor's wind. And then get max x for the column. And now it should be fairly easy to do things. So for I equals 0, I less than get num rows, right, of win. For j equals 0, j less than get num calls of win. Then we said we wanted to do move w add ch on win. And where do we want to move? ij. And what do we want to put there? A fill character. And then we need to make sure that afterwards, well, we move back to the beginning. So it'd be like w move. Does it move? I think it's just, yeah, w move. When to cur row, cur call. And that makes it so that the cursor has not actually moved. And the window is going to be filled, but the contents won't actually be shown onto the screen because we didn't call refresh. Any questions so far? So over here, back here in main.c, board window, and then we might want to say something like w refresh. The address of board window. Oh no, board window dot cursor's win, so that shows up on the screen. And then we're going to make sure that at the end of our game, we kind of like end win right here. So we turn off curses. But what we want to see right now is, well, what has what we've done so far actually shown up on the screen? And to see how many typos I made. Oh, yep. Win, arrow, curses, win. Try again. Win, arrow, curses, win. Try again. And it's going. And hey, we got some stuff to show up. Pretty good, right? Any questions so far? So that was the easy part. So now we have to go over here to like get valid move. If you want to go to where a function's defined at inside of C-line, it's Control B on Windows, Command B on Mac, and it's going to go boom, bring you straight there. So cool. we can get rid of all this. And so how do we want the user to enter input now? We could have it do the arrow keys. Do you want it to do the WASD? Do you want it to do the WASD and the arrow keys? Right? You could do WSAD, IJKL. I mean, it's up to you to how many you want to do. Just make sure if statement's a little bit longer. If we wanted to be able to do the keyboard, what are we going to have to do that we haven't done yet? Keypad, right? So we have to go back if we want to be able to do the keypad stuff. We have to go turn that back on up here, and it's a keypad. Oops, go down here. The window has to be created first. Keypad, and then board window dot curses window. I'm a true. Great. Now we can get the arrow keys if we want to. We might also need to go define versus. Nope, not here. Wherever, it's probably over here and move. No. You still probably have a move called move. And in addition to our struct for the board and the turn type, we probably need what else? Probably that cursor tracked window. Oh, but yeah. Well, we're gonna need to know whether we're out of bounds. We're gonna need to know where the heck we're at. But we probably also need the window to be able to update it. Because notice right now we don't have one to operate on. So pound include curses tracked window dot h. Actually, that's going to need to be there and here. Oh. I guess I should talk about that because that's important. So some of you guys had a great question. You're like, what's up with this here? So in C, when you have your header files, basically you cannot create a cycle of inclusions. So if A includes B, B cannot include A to get things to work. Because if you remember, like copy paste, that's all it does. And the issue happens to do if you have, like, say, in two different files, you have like type 1 depends on type 2 in file 1, and type 2 depends on file 1 in file 2. If you include one in the other, one's going to end up below the other one without knowing whose name it is. And because C goes, again, one pass compiler, it's going to be like, I don't know what that symbol is, and I'm going to give you an error. So what I recommend doing is when you're designing like your structs, is that you kind of design like a little graph that shows ownership, who is made up of what things, and who refers to the other things. For example, a move is not made up of a board, but neither is a board made up of a move. But I have to make one choice of inclusion. Does board include move, or does move include board? So here I decided that board should include move. So inside move.h, I just have to tell it that a struct of board exists. So I can say struct, board struct. This just says, hey, there's a struct called board and it exists, so that I can refer to its types inside here. If you have just this forward declaration, you can only like have pointers to it. And I think accept arguments to it inside the file as well. But you also have to make sure that inside the C file, you include the corresponding H, right? Because no file is going to include a C file. So it's safe. You're going to break the cycle here. But I still need to know actually what's inside of a board to be able to act as members. Because here, all I know is that a board exists, but I have no idea what it looks like or how big it is. Questions on my poor explanation of circular inclusions because I don't have a nice way of drawing quickly? It's just something to watch out for, and like in the project I was going to give you, I had like a ton of circular inclusions in a lot of ways, just because a lot of things needed references back to who their parent was to be able to get the job done. Oops, I don't know what that was. But we'll talk more about that later on as it also becomes more apparent. You probably won't have any circular inclusions in the midterm project. So here we need a cursor tracked window pointer win. Great. Okay. So we want to be able to get input from the user, and so what do we use to do that? Get char, right? The other thing that we might also want to take into account is, no, that's fine. So we might have like our char, yes, input is equal to w get ch, and then we say from what window. So that would be from win versus win. So we get our input, and then what should we do after we get this input? Or even here we might have something like this, while true. So we get the input, and then what should we check about our input? Like what character they pressed, right? So if input, we're going to make it just, for time's sake, equals W. If you want to do the keys are back here. It's key up, key down, key left. So W would be equal to key up, key left. Down. I don't know why there's a question mark there. D would be key right. And what do we want to check to see to confirm their input? Because like they can move around, right? Did they press something to like drop it? Yeah, probably like space or new line. And so so we've gotten this character. What should we do? What? So we have to check based on where we're at right now, what should happen if they're at the edge of the screen. So do you want edge of the screen wrap or edge of the screen stay where you're at? Okay. So if we have when arrow cursor row is greater than or equal to 0, or greater than 0. What do we want to do? Subtract 1, right, from row, and then move the cursor, right? So we need to do something like like when arrow cursor row minus equals 1, and then we'll just do like W move when to when arrow cursor row when arrow cursor call. And that would move the cursor up, right? You also have to kind of like figure out, well, what do you want to display? Like when somebody's playing, like do you want to show them just a little blinky where they're going to put things? Or do you want to show them the character they're going to put down? If you're doing the character they're going to put down, then things get more complicated because you have to take the character that's where it's at, put the character that's actually supposed to be underneath it there, then take that character that you want and write it up one above where you're at. But for here, we'll just have a little blinky, and the little blinky will just keep us where we're at right now. Right? It'll just move and go blink somewhere else. And then so probably want to add some other similar cases down here. And then so here, if this to move to the left, the key has to be greater than 0. This would be cursor call. And this would be like cursor call here. Notice that like a lot of the code that we have is, even though it's kind of small, cursor row is, we want to go down. So it has to be less than or dot num rows minus 1. The 0 based indexing. So if you had 3, you can go 0, 1, 2. So you'd have to be less than 2 to be able to go up by 1. Or maybe it should be less than. So just less than. Oh, you have to be less than 2 because 2 is the bottom one. And then you could do like a plus equals. But again, like a lot of this code is very repetitive. So we probably should do a lot of functions here for like this part, especially like, even though it doesn't seem like much, you might want a function that just says like, you know, move cursor left, move cursor right, move cursor up, move cursor down, right? And so you can call those functions that move a cursor up, down, left, or right, instead of having to like have this like gibberish kind of stuff in there, right? And you could also encode the boundary conditions for moving as well. When cursor call plus equals 1, and then has to be less than or equal to board dot num calls minus 1, and then we move to the position. So here, hopefully, what we'll have done is we've given ourselves the ability to move. And so we'll get rid of this line right now. We'll set a breakpoint down here because we didn't get that far. And try to build it. Oh. Just hold on. We'll get it. This is why you write functions for it. So you're like, hey man, I only gotta change it in one spot instead of changing it everywhere. And C-line makes it really easy to do that refactoring because you can say like curly bracket here, and then this guy matches with this guy. Okay, let's see if we got it working. So can I move? Oh, you know we forgot to call refresh. So again, I've had this problem where it's like, hey, I'm doing stuff, it's not working. Oh, it's not showing up because we didn't say to refresh the screen afterwards. So W refresh Win arrow versus win. Oh, we still screwed up somewhere. What? It built. It just built when I just did it right now. The refresh at the end. I don't think moving to the end is going to affect much. No, we still have some issues. Oh, we got a segmentation fault. That's good.
Yeah. Just to confirm what you were saying. So basically, I mean, I think I was trying to do it, so I think the last curve was still, sometimes still doesn't work. I don't know. Maybe correctly. My procedure work.
So, like, if you just try removing the line.
Which time?
The line of code that we tried to add inside the if statement. So, like, if that line of code of just increasing the number of lines by 1 is gone.
Like, that's my final code that was created.